All right, this is Katie Lagergren here, working on the tax collector problem. I actually have used this problem with my high school students as sort of a beginning of the year preliminary kind of fun task for my students to do at whiteboards to get to know each other, talk about math, and really for me to kind of practice using in some capacity some building thinking classroom strategies. It's a fun problem, and so in this video I am going to complete it for you by following Polya's problem solving process or method. So first, let's read the problem and work to understand the problem. So how to play. Start with a collection of paychecks from $1 to $12. You can choose any paycheck to keep. Once you choose, the tax collector gets all the paychecks remaining that are factors of the number you choose. The tax collector must receive payment after every move. If you have no moves that give the tax collector a paycheck, then the game is over and the tax collector gets all the remaining paychecks. The goal is to beat the tax collector by collecting the most money. So first, to make sense of the problem and understand the problem, rereading certain parts of the question is often helpful for me. So I know that I'm going to start with paychecks from $1 to $12. And I know that in essence, I want to be thinking about what the factors are of those numbers 1 to 12. But ultimately, I'm going to make a choice first, and I'm going to pick a particular dollar amount to take, and then the tax collector will automatically collect the paychecks that then are the factors of that given number. To best understand this problem, trying out the game for the first time without any sort of plan is a good way to go about doing that. So that's what I'm going to do first. I haven't made a plan yet, but to help me understand how this game works, I'm going to attempt it. So I just quickly made a list of the numbers 1 through 12 to represent the paychecks. And I know that I'm going to choose any number, and the tax collector will automatically take any remaining numbers that again are the factors of the one that I chose. So I'm just going to kind of make a list of me and then the tax collector. So I'm just going to, again, kind of at random, I'm just going to choose, let's take the number 8 or paycheck number 8. So that means the tax collector will have or collect all of the factors of 8 that are remaining. So if I go backwards from 8, we would get 4, 2, and 1. Okay, so again, I'm not thinking about any sort of strategy. I'm just getting a feel for how this works. Okay, so maybe I'll take the number 12. And I know I can still take that one because there's a 6 left, which is a factor of 12. So the tax collector, again, with the remaining choices, he will collect the 6, since 6 is a factor of 12 and the only one left. So following the rules, again, if I'm rereading, the tax collector takes the factors of the number I choose. The tax collector must receive payment. So that tells me if I tried to take the 11 right now, I wouldn't be allowed to, because if I took 11, there are no factors of 11 that are left. So I'm not allowed to choose that one. So what other choices do I have? I could take the 10 because there's a factor left, which is a 5. And again, the tax collector would take that one. So the choices that I have left, 11, 9, and 7, I'm not allowed to take any of those because they are all, 11 and 7 are prime, so their only factor is 1, which is already gone. And then I can't take the number 9 because there's no factors of 9 left over. So I'm out of moves, which means the tax collector, if I read the problem again, if you have, let me kind of get my there it is, my laser pointer. If you have no moves that give the tax collector a paycheck, then the game is over and the tax collector gets all the remaining paychecks. So he or she will collect the 7, the 9, and the 11. So now that the game is over and all the paychecks have been collected, we know that the goal, rereading the problem again, the goal is to beat the tax collector by collecting the most money. So if I take a minute to find out our totals, 8, 12, and 10, looks like that is a total of $30. And if I add up the total the tax collector raked in, 4, 1, 2, 6, 5, 7, 9, and 11, I believe that's $45. So the tax collector clearly won through my attempt to try to understand how this works. And so now that I understand how it works, I am going to come up with a plan. So my plan, thinking about now what I understand about the problem, I want to generate the largest sum. And if I want to generate the largest sum, then I want to select the largest paychecks available, starting from the very top, 12, the 11, 10, 9, 8. Having at least, 4 to 5 of those largest numbers would be ideal. But I also notice in these numbers, right, we have some composite numbers, which means they have more than one factor, and some that are prime. And the prime factors, or the prime numbers, I should say, matter kind of quite a bit. They have the least amount of options. If I choose to select a prime number, say 7, its only factor would be 1. And so if I choose the 7, the tax collector would take the 1. And then I wouldn't be able to take any other prime numbers after that. And so I noticed the largest prime number might be an asset to take earlier on in my choices. And then ideally, in my example round to help me understand the problem, I forget what number it was, but I took one number, but it had multiple factors. And so it might also then be a good plan to try to take numbers that only have one factor left in the list. So that's my plan. My plan is to focus on selecting the highest prime number soon, maybe first, and then to try to select numbers that only have one factor left and available for the tax collector to take. Other notable parts of my plan. I have, some kind of visual here. It's not much of a picture. It's just a list of the numbers and then a list as I go through this choice or this activity. But to me, that's a really big part of my plan, is to somehow actually take this step by step. And through that, there might be quite a bit of trial and error. My hope is that this first attempt here is going to generate a win for me, that I'm going to have the largest sum and I'm going to beat the tax collector. But there might be some trial and error to this. Okay, so as I said, my goal is to take the highest prime number and then only select numbers that have one factor left in the list. So the highest prime number is 11. I'm going to select the 11, which means the tax collector would take the number 1. I'd really like to take the number 12, but if I select it right now, then the tax collector will collect numerous numbers, the 6, the 4, the 3, the 2. And so instead, I'm going to find one that only has one factor remaining. And a good choice for that one would be the 9. So if I take the 9, the only remaining factor is the 3 for the tax collector. Next, again, I want to look for a factor that only has possibly one factor remaining. And for me, that looks like it's the 6. So if I take the 6, then the tax collector is forced to take the 2. Because the 2 is gone, selecting the 10 next, or sorry, because the 2 is gone, and the 3 is gone, and the 6 is gone, selecting the 12 next would be a wonderful idea, because then the tax collector can only choose the number 4. Because the 2 is gone, I can select the 10, and the tax collector only gets the 5. And now it looks like I am out of moves. The tax collector, because I can't pick the 8, there's no remaining factor, and I can't pick the 7, there's no remaining factor. For me to for the tax collector to select, he will automatically get the 7 and the 8. So let's see how I did. So it looks like I did indeed beat the tax collector. My sum was greater than 48. My strategy, my plan did work. To kind of look back and make sure that I've done my calculations correctly and I didn't break any rules of the game, I'm just going to retrace my steps to make sure that I didn't miss anything. So I started by taking the 11. Only factor left of the 11 was the 1, so that step checked out. I then chose the 9, and the only factor left was the 3, so that step looks correct. I then chose the 6. The remaining factors for 6, less than 6, it was only a 2, so again that works. I chose the 12 next. The only factors of 12, not 10, 8, 7, not 5, but 4. Looks good. The 10, the remaining factors, 8 and 7 do not work, but 5 does. And there was no moves left for me, so the tax collector got 7 and 8. So looking back, it looks like at least I followed the rules of the game, and I still did beat the tax collector, so there was good success. So when I have done this, it's been an entire year, actually, a little year and a half. So I didn't do it this fall, but last fall with we call it advanced algebra, my algebra 2 students. It was like, I think it was the first day of school, in fact. It was really fun to see my students process this. And it was probably the most fun to see them try it without really thinking and fail. And then they got really kind of competitive and wanted to figure it out. So it was just, I should say most of them, not all of the students. So when I did it with my classroom back then, I kind of had some extra questions with them of, you know, is it even possible to beat the tax collector? What strategy or what might you consider in order to try to beat the tax collector? And additionally, what if what if there was more paychecks? What if we use the numbers 1 to 24, or 1 to 25, or 25 to 50? And so it was some fun extensions that, if you're looking to use something like this within your own classroom, some fun extensions and add-ons to do. What I'm kind of curious about that I have not taken the time as of right now to also then think about is how could I generalize this? Is there sort of an additional pattern here at this point with what I hypothesized in my plan, something that would work? It did work, and so I wonder if that same thinking would continue to work even if the number set got larger. And a reminder, my plan was to consider first a prime number because that would have the least amount of options for the tax collector to then respond with for their turn. And then trying to select numbers within the list that only had one factor left over to try to generate fewer options or fewer total numbers, not necessarily sum, not a less sum, but less options for the tax collector to collect the money. So I would guess that that plan and that strategy would think for slightly different variations of this problem. And again, I would, if you choose to use something like this in your classroom, I would ask your students those questions as well.